Nice to be here for in-person events. And I hope you're all very excited to hear about one of my favorite topics, which is JavaScript and beer. So I'll talk a little bit about a bunch of different things in this talk. I'll start a little bit by talking about IoT and why maybe you should care about IoT devices. First of all, well, apart from the fact that it's a lot of fun to hack on IoT devices, I mean, there's more and more devices every day. They're taking up a lot more place in our day-to-day lives. They're used everywhere. A lot of them are in industrial settings. And I think it's predicted that there will be somewhere around like 75 billion connected devices by 2025. That's crazy, like 75 billion devices, and that growth just goes like, it just skyrockets. And I was like, oh, well, you know, probably because the world population is increasing, but that's definitely not like, the same mapping. And I was actually looking at those numbers, and the average right now is 6 internet-connected devices per person on the planet. Like, that's the average. And I was like, there's no way that can happen. So I started thinking about, all right, what do I have at my place that's connected? And of course, I've got laptops. I've got a couple of laptops. I've got 2 for my work. My wife also works from home, so she has her laptops. I've got 2 cell phones, so we each have our own. We also have 2 tablets. I mean, so far, some people could argue that those are not IoT devices, but they're still connected to the internet. Right? Now, what else do I have? I have my smart thermostat, which I can control from whenever I'm traveling, which is nice. Smoke detectors, also very useful. If there's a fire at home, I'll actually know. Not that I can do anything about it, but I'll know. I've got my smart TV, which is connected, to Netflix and all that stuff. I've got a couple of light bulbs that I've connected. I've got some plugs, just that you can plug, so my Christmas lights are on that. I've got, speakers. I've got a Sonos speakers, so 3 of them are also connected on the internet. Home assistants, I've got 3. I actually just got a Wi-Fi router, so I actually now have 6 of them inside my home. My door locks are connected to the internet. There's, what else? My vacuum is connected to the internet. And of course, my fermenters, but I'll get back to that later. But that's 28 devices, and for a household of 2. Maybe 20 if we exclude the laptops and cell phones. But that's still 10 devices per person. So IoT devices, should you care about it? Yeah, because they're everywhere, and it's important that we learn a little bit about how you can use them and how you can use all the data that comes out of it. So before I jump into our topic, hi, my name is Joel. I work as a developer advocate for MongoDB. If you ever want to get in touch with me, Twitter is always the best way. So I'm Joel __Lord on Twitter. There's 2 underscores there. It's like the worst Twitter handle ever. Fun fact, I only realized a couple of years after I had that one that Joel Lord in one word was also owned by me, but with a different email address, and I kind of forgot about it. I'm based in Ottawa, Canada, actually on the French side in Quebec. So that's the lovely little French-Canadian accent that you might recognize there. All right, so today we'll talk about JavaScript. We'll talk about IoT, how you can use JavaScript and IoT together to create projects. We'll talk a little bit about beer brewing. So one of the things with the pandemic, I don't know what happened, but my attention span just kind of reduced. The only thing that I watch nowadays is just like a video on YouTube, 5 minutes, like at 1.5 speed, because then I want content. So I think that like a full hour is a lot of content. So I'll split it up in the middle. We'll talk a little bit about beer brewing, just for fun. And then we'll get back to sensors and data. And there's a link, like everything will make sense at some point. So IoT and JavaScript, like pizza and beer. My original slide was like PB&J. I was like, oh, that would be funny, pizza and beer, and I couldn't find anything with a J. So it's just like pizza and beer. So IoT and JavaScript, they work together very well. There's a lot of ways you can integrate, and you can actually program IoT solutions using JavaScript. Of course, JavaScript is everywhere, so you can use it on your front end, which is also applicable if you have a IoT project, so you can use whatever framework that you want. You can use it on the back end, so you can use Node.js, or we'll look a little bit at serverless solutions here. So you can use it there. You can also use it well, kind of for your database, and especially the serverless part of your database connections. And you can also use them for IoT devices, which is really cool. So I really like JavaScript. When Node.js came out a couple of years ago, I really went all in. The main reason being that I find it really hard. Context switching is hard, and programming a different language for both front end and back end is really hard for me. But it made so much sense to use the same language everywhere. So I've also started using it for IoT devices whenever I can. So this is a project that I did, a talk I did a couple of years ago, where I had this little robot which uses an Arduino, and I had a Kinect that was plugged into my computer, and you can see in the back there's the skeleton that is detected, so that I took the input from my Kinect, draw the skeleton, and I built a library that would detect gestures, so whenever I would swipe, my robot, also programmed with JavaScript, would just jump off the table. So, and all of that was done with JavaScript. Like, it was such an exciting project. I really, really liked that. And it was nice to be able to use that same language everywhere. Now, JavaScript can be used on small microcontrollers. The one example that I've just shown you was using an Arduino. You might be familiar with the Arduino. It's an open source microcontroller that you can buy for, they're like $5 a piece now, or cheap knockoffs. And you can technically use JavaScript on it, but you need to install, to flash it with a software which uses C, and then you'll be able to communicate via a standard protocol with your JavaScript application. So not ideal. Also been 2 years since I gave a talk, and I forgot how to breathe while I'm speaking. So sorry. Okay, so you can use an Arduino, not ideal. Espruino is a new microcontroller that came out that you can actually program using JavaScript. So really, really cool, fun stuff. So you can use directly your favorite language directly on the microcontroller, flash it with your JavaScript code. There's some magic that happens behind the scenes, and there you have it. You've got your microcontroller programmed, and there's also the Raspberry Pi that can be used. The Espruino looks a little bit like this. I actually have one right here, if you want to take a look at it later. Cool little device. It has Wi-Fi directly on the board. It plugs into your computer via USB, and it can be programmed with JavaScript. So just plug it in your computer and get started in seconds with the web IDE. No software installation needed. That's from the website. So this is what the web IDE looks like. So you can actually directly go to espruino.com/IDE. You plug in your device, and you can program it directly from there. You can flash the device using web USB, and it'll just flash the device. It doesn't work well in the knife frame, so I actually have it right here. So I can, and I realized something like just 2 minutes before the talk, because I've been doing a lot of virtual events recently, and at virtual events you can do things like take your camera and show an actual tiny little device like this, which nobody here can actually see, which I just realized later. But you'll just have to trust me on this one. Let me open my hotspot. There it is. Let's reconnect this. There's a red LED going on, so probably something's not working. But there you go. So it should be trying to connect to the internet right now. There it is. And I can connect to the device itself. And that's all using a web interface. And you can see that it was connected to it. You've got some lights going on. And I have a temperature sensor here, which I use to just monitor the temperature. So I was just looking for a relatively simple example that I can carry in my luggage through the customs without having like too many wires and without it looking too suspicious. So this is what I have. So it just detects the weather and sends that data to a server somewhere every 5 seconds or so. When you're starting with IoT devices, so this is the actual code for it. I'm not going to go through all of the code because there's a lot there. But basically what it does is that it connects to the internet, connects to a Wi-Fi, and then it will just start to send that data from the sensor. The hello world of any IoT application is always the blinking LED. There's most devices, plenty of devices like this one have a LED built on the board, so you can actually directly try to experiment as soon as you've got the microcontroller and a USB cable. So what I do here is that I just set the state to false, and every 500 millisecond, I change the status, and I'll just write that to the LED, and the LED will start to blink every 500 milliseconds. So that's kind of what the code looks like at its most simple, Hello World-esque type of application. You can also use a Raspberry Pi. Raspberry Pi is a little bit more, it's actually a tiny computer. It's a full computer. You can see it here. That's an older version, actually. No, I don't know what version. No, that's the right version. That's the new one. So you can see that it has two HDMI outputs, mini HDMI, so you can actually plug in some monitors. You've got a couple of USBs, so you can plug in a keyboard and a mouse. And off you go. You've got an Ethernet cable. There's also a Wi-Fi chip on board. So you really have a tiny computer that you can use. You can program just like you would with any other computer. But what's interesting about it is that it has all of those pins right here in the back. And you can actually use those pins to plug in some things like the sensor. And then you'll be able to access those pins and get the data from it. So yeah, also from the website, very markety. So if you want to use that, if you want to use JavaScript to power your Raspberry Pi, just use Node.js, use npm install the Johnny5 library, amazing library to work with IoT devices. That's the one that you can also use with an Arduino. And this is what the code looks like. So you just initialize your library, initialize your board, tell it that it's a Raspberry Pi right here. And then whenever the board is ready, you can do things like using the LED.blink. So you just declare your LED, and then you can use the blink method, and it will just do that blinking. So once again, nice, easy to use. Very convenient that you can use JavaScript there. You can also use, because it's a computer in itself, you can also use just about any programming language. A lot of projects are using Python as well on Raspberry Pis. So Espruino versus Raspberry Pi, which one should you use? It really depends on your use case. Raspberry Pi is convenient if you actually need a full computer. If you just need a microcontroller, just a tiny something, a tiny application, then the Espruino is usually a better choice. Both of them are also available for commercial projects, but you'll need to design something with the boards. I'm more of a hobbyist, so I've never built an actual real commercial product with it. All right, so that's it for JavaScript and IoT. Let's take a small break. Let's talk about beer. Anyone's up for a beer? Be right there. There you go. So, I don't have a lot. It's a great Canadian lager. So it's called Moosehead. Well, there you go. Sorry. That's it. That's all I had. I had to smuggle them through the border. All right, let's talk about beer. Beer 101. Who's that? Sorry. All right. Oh, yeah, you have to be 18 years or older, or whatever the legal age is. It's 18 back home, so whatever. I realize the irony of this while I'm having a beer right there on stage at 11:30 in the morning. But I am in no way encouraging the abuse of alcoholic beverage, and that's an important thing, and I think it's important to mention it, though. Not everybody has the same history or relationship with alcohol, and if you ever want to chat with me, I'm more than happy to just have a coffee. You don't have to drink to be fun, or so I like to think. All right, what are we going to talk about today? We're going to talk a little bit about a definition, so just that everybody knows what a beer is, so just so that we're all on the same table. We'll talk a little bit about the ingredients that we need, the process to create beer, and finally, we'll talk about the end product. So a little bit about me. Hey. So based in Gatineau, Quebec. One thing that you might not know is that I'm also master brewer and co-founder of Brain Brew Canada. So brainbrew.ca is our website. We've got great products, but don't look for our products in store. That's pretty much what our setup looks like. That's actually my small setup. We've got a little bit of a bigger setup, which is a 20-gallon that we can brew with that. And we usually try that one. The smaller setup is more for small experiments or just fun little hobby things. So this is what we usually brew. But if you're ever in the area, feel free to drop by. I'll be more than happy to serve you one. I usually have 5 taps at home, so that's my big fridge, and I also have another tap which is available. One of them is water in that one, but yeah, it's still like nice sparkling water. All right, let's talk a little bit about the history of beer. So we'll cover the whole history, where it started. Actually, just before, we'll talk a little bit about what is beer. So everybody familiar with the beverage? So it's elaborated from grains. The fermentation process will produce alcohol between 4.1 and 5.5. That's a legal definition in Canada, at least. Less than that is actually not a beer, it's a light beer. And more than that, it's not a beer, it's a strong beer. That's the legal definition. So the history of beer started 11,000 BC. That was like the first archaeological evidence that they found some beers or production of something similar to beer in Israel. 8,500 BC is when they also found some beer produced at another site over there. So and then when they started using barley, which is the main ingredient which is used nowadays, that dates back 3,500 years ago. And that leads us to the creation of Brain Brew in 2016. So, all right. So let's talk about the ingredients. Everybody's familiar with how we make beer. So there's 4 ingredients, that's it. That's actually the law in certain countries. You've got to use only those 4 ingredients, but a lot of places, like in the United States, they'll actually add a few things there. But water is the main ingredient. Water is very important when you're making your beer. 95% of the final product is actually water, the other 5% being alcohol. Your pH should be balanced. You usually aim between 5.2 and 5.6, so slightly acidic, but tap water is perfectly fine. There's a lot of science behind the taste of water and how it can actually change the beer. I've actually it was here, it was in Atlanta. I went to a brewery and I was speaking with the master brewer, and he was more than happy to share his recipes because he said, well, you know what, the water is different at your place, so you're actually not going to be able to reproduce that exact same beer. It will be different, and it did taste a little bit different. The next ingredient is grains, so you need some barley, some wheat. There's a lot of grains that can actually be used, but typically it's barley. So the grain is germinated and then dried, and then it's roasted at different temperatures, so that's the malt that is being produced, and it will be roasted at different colors. The starch from the grain then will become fermentable sugars that will make the magic happen. When people think of dark beer, they usually think of dark grains. This is actually what a porter would look like for your grain bill. So there's those tiny little speck of black there. Those are roasted grains, and that will be enough to color the beer, like a Guinness. So just to give you an idea, porter, a recipe that I have is 76% base grain, so that's just your barley, malted barley, a little bit of wheat there, just for extra gluten, just for you, Chris. A little bit of wheat, it helps with the taste. Crystal is just to color it a little bit more, so it's slightly colored, a little bit more sweet, adds a little bit of sweetness to it. And chocolate malt is a malt that is very dark. That's the dark speckles there. And it actually tastes a little bit like chocolate when you taste it. It's really good. And then carapils, which is used to make a little bit of foam. Compare that to an IPA. Well, you've got 88% base grain, a little bit of slightly less colored grains, and then 4% of carapils. So really, you can see that there's about a 10% difference in the grain bills between an IPA, which is usually very blonde, and a porter, which is very, very dark. So this is the Lovie-Bond scale. This is how you measure the color of your beer and how you can measure the expected result at the end. Well, you've got hops. Hops are very important, very popular, especially in the United States. Actually, you have a lot of very strong hoppy beers. So it's a recent addition to the process. It's kind of new. So it started about 822 AD. Responsible for the flavoring of the beer. So if you've tasted one of those IPAs, that's where it comes from. It's all about the hops. And it really contributes to the bitterness of the beer. So when you've got a bitter beer, it all comes from those hops. There's a million different hops that you can use for your beer. They each have their own profile. And then you pick whatever you want. So if you make something like a New England IPA, you would use something like Cascade, Amarillo, more citrusy, more floral. But if you want to build like a strong West Coast IPA, you'll go with Chinook, which is very piney. I'm really passionate about beer. I could talk about that all day long. Then next you have yeast, where the magic happens. Introduces a little bit of character and flavor. So the choice of yeast will actually have an impact on the final beer, the final taste of the beer. Interestingly, you can cultivate it. So basically, you just need like one bacteria because it's a bacteria. You just need one, and then you put it in some grain juice. Looking for the right word there, and it will just reproduce itself, and then you can put that in your beer. Or you can even find some in the nature. So I actually tried to experiment some beer with that. So you basically just take, you start preparing your I'll call it grain juice, for lack of a better word. And then you just put it outside and wait for a couple of hours, and something will fall in it, and it will just start to reproduce, and eventually you get beer. Kind of a dangerous thing to do, but it works. All right, how do you make beer? You've got a hot liquor tank, you've got a mash tun, and you've got your boil kettle. So you've got those 3 big kettles that you use. You start by mashing. So you put all of your grains, put some hot water in it, 152 degrees. You leave it about 60 minutes. It extracts all those sugars, all those starches that you'll be able to use in your fermentation later. Recirculate a little bit just to clear up and remove any excessive grain that might have fallen in it. And then you boil. So you boil for about 60 minutes. And that's where you'll start adding your hops. So the hops, the earlier you put them on, the more bitter your beer will be. And then you chill your beer. So you want to bring it back to 20 degrees Celsius. Fun fact, I use Fahrenheit for like higher temperatures. Like it boils at 212, but I have to bring it back at room temperature, which is 20 degrees Celsius. I don't know what room temperature is in Fahrenheit, but hey. All right, you do that with cold water. That's a plate chiller. So water goes in, the wort, not green juice, wort. Wort goes in the opposite direction, and it just cools down the wort, and you're ready. This is for smaller batches, so it's just a copper line that goes in it and cools it. Or, you can just chill the Canadian way and just put it outside and wait for it to get colder. And then you've got your fermentation that starts. Fermentation is always the same thing, so it's just a little bacteria that will basically eat all of the sugars and then, fart some CO2, and it will produce different things. So it can produce bread. This is my starter for my breads, or you can actually produce some alcohol in your beer. So this is some of my fermentation. The one on the right actually was so active that it started foaming and it just popped up and it made quite a mess there. And if you want to measure how much alcohol you'll have in your final product, what you'll want to do, and this is where it starts to be interesting, you'll actually want to measure the level of sugars that you've got at the beginning and the amount of sugars that you've got at the end. And with that, you know how much alcohol you now have because the sugar was converted to alcohol. So that's how you calculate the difference. My cats absolutely love when I have my wort and there's a little bit that was because it's very, very sweet at that point. So they'll always jump and try to lick the thing. So water density will change based on the amount of sugar that you have. This is a fun experiment that you can do with your kids. You take different water color, put some food colorant in there, and then add like 1 teaspoon of sugar in the first one, 2 in the second one, 3 in the second, and the third one. And then you can layer those different waters because they have different densities. So that's how you measure sugar. Basically, you use the same thing. You measure the water density. You can use a tool like this one, which is called a refractometer, which gives you different measures. Or you can use something like an accelerometer. I can never pronounce that word. And an internet-connected device to actually measure the amount of sugar that you have in there. And now that you've got that, well, you can keg your beer and you've got your final product. So this is actually our bottles or our growlers that we use. So that's all I had. So santé, thank you. All right, but we're at a tech conference, so let's talk about the actual tech component in there. So this is the device that I've used. It's an open source project called the iSpindle. And they use an Esprino, and there's an accelerometer in there. And because the water density changes, the actual inclination of it will change based on the amount of sugars that you've got inside of your fermenter. So based on that, it measures basically the gravity pull, and based on that, you can actually measure how much sugar you still have in your beer and whether the beer is ready or not. So when it gets very close to 0, then your beer is ready. So it's built on an ESP8266, so exactly the same technology as I'm using right here, and it transmits the angle and the temperature of the beer, which is also very convenient and fun to watch during the process. So this is what I've used, and then I'm getting that data, and then what? And that's the thing with IoT. It's not about the actual devices themselves. They're, they're very cheap. You can actually have one, start to explore, play a little bit with it. It's a lot of fun to do. But when you've got a production and you've got some IoT devices out there, what you really want to manage is not the devices themselves, but the amount of data that they'll produce, and they will produce a lot of data. Of course, my fermenters push 1 reading per hour, and I've got 2 of them, so it's very manageable. But if you have a commercial product, then those are things that you'll want to start to think about. So you'll have to think about how you're going to architect that whole IoT project. Typically, all IoT projects are very similar. You've got some devices or actuators, some things that will act based on whatever is happening inside your devices. You will have some sort of internet gateway. Now, the ESP8266 is very convenient because it actually has a Wi-Fi chip. So the internet gateway that you can use is the home router that is available for you. So that's why it's very used in B2C projects, so consumer devices. But if you're looking at industrial projects, they'll often use protocols such as Zigbee or Z-Wave so that it can create a mesh, and each of those little devices, they can all interact with each other and help to build a larger network for more redundancy. Then you'll push all of that data either through the edge if you want to pre-process all of that data, or straight to the cloud. If you've got 1 reading every hour, no need for pre-processing. And then you'll need to store all of that data and parse that data somehow. So this is what my setup looks like. So I've got my 2 fermenters. They're connected to the internet, and I patiently wait. Then that data is then being, there's a new reading every hour, pushes that to my home router, and that is then sent directly to a Realm function, which is a serverless solution that we have at MongoDB. And then it's all processed inside of our cloud platform. At this point, so we've got the database where I will store my data. I'll have some charts that I can produce out of that. I've got some database triggers that I can use, and the aggregation pipeline to get some statistics. And then I display that either on our website. So if you're interested in knowing what's brewing, you can actually check out our website. And another fun thing that I've recently added is that I'm getting a notification when the beer is ready. So I'll get a text message. My fermenters will actually send me a text message saying that the beer is ready. Very convenient. So serverless, I've used Realm functions, like I said. There's a lot of different serverless solutions that are available. AWS Lambda is one of the most popular one. I'm sure Google has one, probably, on the cloud platform. So this is what it looks like. Once again, you can use JavaScript. You can write your small functions. So you'll write a small snippet of code. What I do here is that I actually have, where is it? I've got my functions. I've got one that is called write incoming, so it'll just take whatever, it'll expose an endpoint, and whatever data comes through that endpoint, it will just take it, add a receive that timestamp, and then it will just append all of the data and just insert that into my database. So very, very simple endpoint, and I've used it when I connected this, which apparently is not working. I'll give it one last try. But basically what will happen is that this little device will check the temperature and then send that data to that endpoint, which will then be stored to our database. So I can go to the actual database, take a look at when's the latest document, 10:15, probably not really the latest reading. I don't know, but it just sends it. And I can see that it's 21 degrees and 30% humidity in the room at the moment. Of course, I use the same type of thing for my fermenters, so it just sends the temperature and the gravity data that I pick up from it. The code is a little bit more complex, so I just wanted to have a simple example here. I've just shown you the actual database where I can extract that data. I've shown you the database, but what I usually use is this really cool tool, but let's not talk about that for now. And finally, you'll want to query all of that data. You'll want to get some things out of it. You'll want to do some statistics. You'll want to explore that. And to do that, if you're using MongoDB, you can use what is called the aggregation pipelines, as well as the functions that are available to you. So the aggregation pipeline looks a little bit like this. So it's just a series of different things that you want to perform in order to extract that data. So in here, you can see that I'm adding different fields to the data that I've just extracted from the database. I convert the temperatures into a numeric format, and then I just take the average temperature and average humidity level so I can know what's been the average over the last hour or so in this particular room. Not that it's very useful, but this is the kind of the type of things that you can do. If you store them inside of a function, once again, you can just query that function, query that endpoint. You have access to that data. So you can just use a regular fetch just as you would with any other endpoint. The nice thing is that you don't need to have an actual Node.js server to manage all of that data. You just have those little endpoints that you can directly fetch data from. So what I'm doing here is that I'm actually sorting all of that data in my first step right here. I'm sorting it in descending order, whatever, latest first. Then I limit my results to 1, so I just want just the latest result. Then I'm adding my temperature and humidity into a numeric format, and then I just extract those two numbers, which is all the information that I need for this page right here. So you can see that the latest reading was at 10:35. So just before, as I was testing, and of course it stopped working as the minute I entered the room, like everything just crashed. But the last data that I was just what I was getting prepared right before this talk. So it was 21 degrees and 39% humidity. So just a simple fetch, and you're able to extract all of that data. Another fun thing that I've recently discovered is that you can also watch for changes, which can be very convenient in something like that. So you don't want to poll your database to see what's the latest reading all the time. Maybe you just want to wait until some data actually gets in to be able to display that data. So what you can do is just to use the where is it? Collection.watch method, and then you will receive something, and it will trigger that callback every single time that there's either a change, an insert, delete, anything inside of your database, any change inside of that specific collection, because you're watching a specific collection here. So this is what I'm doing right here. Of course, the poor little device is not working, so it'll stay at 0. But just to demonstrate it, I can actually take that database here, pick up the latest document. Doesn't matter which one, actually, and I can just change the data. I'll say that it's 21, and need to click update. And there you go. So it immediately told my application that there was a change in the database, and I was able to parse that response and immediately show the latest result on the web page. So it uses WebSockets behind the scenes. There's a lot of technology involved behind the scenes, but it's very, very easy to use and very convenient for exactly this type of application. The other thing that I've used, of course, I wanted my fermenters to send me a text whenever my beer is ready. So I've used database triggers as well for that. And once again, they work exactly the same way. So you've got triggers in here. You can just specify, give it a name. So I'm checking if the temperature for my device is too hot. So once it reaches 25 degrees, it'll just send me a text message. And basically, I just tell it to trigger a specific function, which is just like the other functions that I had earlier. Is temperature too high is the one where I just, and now you all have my phone number, where I just use that and send a text message. So very, very easy to use. It integrates directly with Twilio, so you can use Twilio directly on your Twilio account just to use to send the data. I actually built this demo, and I swear it was working, but I built it last night after I had a couple of beers and I came back to my room. So it's that simple. Like you can actually program that after you've had a few drinks the night before your presentation. So right, pretty cool, right? So far? All right. I needed to put that GIF in there somewhere. So yeah, so that's all the different things that I would say be able to use. A lot of really cool stuff, cool technologies that I've been using. Another interesting thing that I also almost forgot, but reporting, I'm using charts here. And basically, I can go to my What's Brewing page on brainbrew.ca. And we can actually have the live status of our charts. So that is all built in the product, built in MongoDB, so you can directly use the charts and embed them in your website. So you can kind of see the graph here. So within the first couple of days, there's a rapid decrease in the sugar levels. So you can see that's the green line at the bottom right there. It's a rapid decline. There's also a slight peak in heat. So as the bacteria are reproducing, because they're in love and they throw out a little bit more heat inside in the fermenter. So that's a natural part of the process. So you can kind of see that little bump here. The blue line is the temperature that you get. And when it reaches that flat line at the bottom, then I know the beer is actually ready. So typically you'll leave it a little bit longer, just because it kind of helps with the process, and the flavors are a little bit more present when you leave it there longer. But if you're doing commercial beers, such as a Molson X or a Labatt Blue or whatever, trying to think of an American name, can't find one. but it'll take between 2 and 3 days to actually get that flat line immediately, and then they bottle it immediately and they just ship it. All right, so that's pretty much all I had today. So hopefully you've learned a couple of things, IoT and JavaScript. So really, you can use JavaScript everywhere, very convenient, front end, back end, and on your actual devices. So if you have an ESP8266, you can actually use JavaScript directly on it, which is very, very cool. Beer brewing basics, so you are all beer experts now, and I hope you'll look at your beer a little bit differently later tonight. And of course, sensors and data really being the biggest part of your project. When you'll start dealing with IoT, you'll get all of that data, so hopefully you'll have a good structure and you'll be able to process all of that. Well, that's all I had, so thank you very much for attending. And if you need any more information, there's a couple of links that I'm sharing at this single link right here. And if you ever want to reach me, Joel__Lord on Twitter. Thank you.